You may have heard about the Phoenix mission, and in fact, just last week, we actually did complete fake landings. We landed safely, and we went on and did a first week of the Mars mission.
In elementary school, I was introduced to a lot of things like dance and equestrians, and I just kind of gravitated towards engineering. So I decided to go to a high school with a bunch of other nerds that turned out to be Clark Magnet, and I saw the robotics team and said, I'm going to do that. And so I did that.
Basically, we can talk to the rovers twice a day. So we designed these rovers specifically to go be geologists, look for signs of water.
I like electrical engineering and computer engineering, and I think in the future I could become part of that community.
These are great students. I think they have some vague idea that they're headed for a career in this field. We've been supported by JPL engineers since we started 6 years ago.
Exploration is a intrinsically human endeavor, and so our proxies for that exploration would obviously exhibit the same kind of qualities that we have. They think for themselves, they respond to their environment, they're self-aware, and they're subject to the unknown. They react to that.
So we're racing to build this beast, Mars Science Laboratory. All that stuff you're looking at will be on the surface of Mars eventually.
This isn't just about science. This is totally about art and creative thinking.
Yeah, it is creative.
Because we got to Mars because people thought way outside the box.
You need people to see things from different kind of perspectives. And sometimes that's a cultural difference. Sometimes it's where you were brought up, what school you went to, what country you came from. It takes everybody to really understand, and as a team, how this thing's going to work, how we're going to build it, how we're going to test it. If everybody thought the same, it'd be a disaster.
Hope to see you again soon.
Thank you.
Thank you so much. Thank you. Bye, guys. Thank you.
It was a great experience, especially when we got to see some of the actual robots that they were working on. We had never seen anything like that before.
We're supposed to create some kind of art project that represents the JPL community, and you have different teams working on different aspects of the robot, and then they're all able to come together and they become successful. And so we wanted to represent their community with just different bars that are kind of separated, but then they're all tied together at the same time.
The main idea behind the actual design is that none of the posts are actually supposed to touch each other. They're supposed to only be held together by strings. It's called tensegrity, which is a combination of tension and integrity.
Got it.
Okay.
It's more fun to work with a team, and it's easier to work with the team. And that's basically what they did at JPL as well.
Do you have the drill bits? Where's the drill bits?
This is going to be something really great to put on a resume because you're saying, look what I did. I helped build something that everybody can enjoy. Look what I accomplished.
Come on. Go, 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 go. Got it.
Most people don't really associate art with engineering or science, but they're all interrelated. It's because of this creativity and curiosity that scientists and engineers want to actually look for things, water on Mars, and explore the universe.
Hey guys, can we rotate it up and see if we can...
People are always looking for leaders, and it only takes one leader to get a huge group of people going. Being able to do this project kind of makes you a leader.
No, just pull it close, like really close.
After spending all these hours thinking about how to piece together something, and it's just exciting to see it all come together.
It's standing!
Progress!